All right, so in the last video, we started talking about absolute value equations and how to solve them, okay? In this video, I want to keep it, it's going to be a little bit shorter because I just want to take what we did in the last video and kind of just extend it a little bit more, okay? So in the last video, uh, one of the last questions we did was similar to this one, where it was the absolute value of negative 2n plus 6 and then minus 2 equals 4. Okay, and then the idea was that whenever we have these absolute value bars, we do need to split this into two different possibilities, right? There's a positive case and a negative case. But in order to do that, those bars have to be alone. Like there can't be anything next to it or attached to it, right? So the negative 2 over here, that's the first issue we have to take care of, which is not a big deal, right? We can move that to the other side very, very easily. The opposite of a negative 2 would be plus 2. So we're just going to add it over here, okay? And if you need that line to show your left side and right side, there it is. Okay, this is zero pair. Bring down the leftovers. We have the absolute value of negative 2n plus 6 equals, and 4 plus 2 gives you 6. Okay, now those bars are alone. Like there's nothing attached to it, there's nothing in front of it, it's just the bars. So now we can actually split it into our two cases and get our two answers that way. Okay, so let's split it off two ways. So positive case, remember, don't change a thing, just write it out. It's negative 2n plus 6 equals 6. And then the negative case, just change that right-hand side to be negative. So we get something like this. Negative 2n plus 6 equals negative 6. Again, the only change is that negative. Okay. Now we solve these two equations separately and we get our two answers. So for the purple one, okay, there's that line, it's your left side and right side. Let's go and get rid of that 6. So the opposite of positive 6 is negative 6. Whatever you do to one side, do to both. Okay, zero pair. So we're left with negative 2n equals, and then 6 minus 6 is 0. Okay, not a problem. We can keep going. Okay, to get rid of that 2, it's attached, so let's divide both sides by negative 2. So the negatives cancel and the 2's cancel. And nothing divided into two equal piles is still nothing. Okay, so one of our answers is 0. Perfectly fine. 0 is definitely an acceptable answer. It's a number just like everything else. Okay, now for the other one. Okay, so the steps are going to be the same, right? Because the only difference is that negative. So let's go and get rid of that 6. The opposite of positive 6 is negative 6. Do it to both sides. And here's our first difference. Now we have negative 2n, but negative 6 minus 6 is negative 12. Okay, and then let's divide by negative 2. Negatives cancel and 2's cancel. On the right side, it does work out perfectly. All right, the negatives do cancel each other out, and 12 divided by 2 gives you positive 6. So your two answers in this case would be 0 and positive 6. Okay, so this was the strategy we looked at in the last video. The only thing I want to do in this video is I want to extend this one little piece further. Okay, so we go and scroll up and I'll show you what I mean. So let's take what we did and let's go one step beyond that. So what if I gave you an equation that looked like this? So 6 and then the absolute value bar, 1 minus 5x, absolute value bar, minus 9 equals 57. Okay, now there's actually a lot going on here. So this is actually a very complicated question. Okay, but remember the concept is the same. You need to get those bars alone, so then you can go and split this into two different possibilities. Okay, but the problem, there's two issues. I'm going to highlight them. Okay, the negative 9 is one of the issues, and the positive 6 over here is another issue. Okay, we need to get rid of those before we can do anything else. Now, compare this absolute value equation to this equation off to the side. Oops. 6 parentheses 1 minus 5x minus 9 equals 57. These look almost identical, except one uses absolute value bars and the other one uses parentheses. For the one that uses parentheses, we were doing these not too long ago. Remember, the idea was you could take that 6 and you could multiply it to the pieces on the inside. You can't do that with the absolute value bars. Think of it like a wall. This 6, you cannot go into that wall. It's completely blocked. Okay? That 9, let's go ahead and take care of that 9, just like we did in the previous example. That one's not too bad. So let's move this 9 to the other side. It's negative, so let's add it over here. Let me draw that line so we can see left side and right side. Okay, so we still have, these are going to cancel. We still have the 6 and then the absolute value, 1 minus 5x. Okay, and then on the right side, 57 plus 9 is 66. Okay, now I still need to take care of this 6, but I can't distribute it inside those absolute value bars. Okay, so we have to do something else. Now, if you were to read this out, it is technically 6 times the absolute value of 1 minus 5x. So technically there is like you could put like a multiplication dot in here. It's technically saying 5 times the absolute value. So there's actually another way that you can get rid of that 6. Okay, instead of trying to distribute it, because we can't, because it's multiplication, we can do the opposite of that. Okay, the opposite of multiplication would be division. So what we can do is we can actually divide the entire left side by 6. Okay, that will cancel the 6's out. Again, whatever you do one side, you have to do to both. So don't forget to do it over here as well. Okay, the whole reason to do that is so that these 6's cancel each other out. Again, we can't distribute that 6. We have to cancel it out another way. So we'll just divide it to the other side. Okay, let's go ahead and simplify. So we have the absolute value of 1 minus 5x. And then on the right side, we have 66 divided by 6 gives you 11. Now we're back to what we're familiar with. Now you can go ahead and split those the equation up into its 2 cases. Okay, so again, this is a very long question. It's very, very intricate. So let's split it up. So we have 1 minus 5x equals 11. Remember, positive case, don't change the thing. And then your negative case, 1 minus 5x equals, and again, all you do is change that 11 to be negative 11. That's the only change you make. And then we solve these separately. Okay, let's go and do the purple one. We want to get rid of the 1 and the 5, but whatever's attached, we'll save for later. Let's go and get rid of that 1. Okay, it's opposite of a positive 1 is a negative 1. Let's go and do that to both sides. Hopefully, as we do more and more of these, the solving the equation part, hopefully it's getting easier and easier for you guys. So we're left with this, negative 5x equals 10. And now we can divide both sides by negative 5. Okay, the 5's cancel and the negatives cancel. So our first answer, after all of that work, 10 divided by negative 5 is negative 2. That's one of our answers. All right, almost done. Now we got to repeat the process over here. Okay, again, same step. Let's get rid of that 1. Let's subtract it. Both sides. Bring down leftovers. We have negative 5x. Okay, negative 11 minus 1, where you spent $11 and you're spending $1 more. You spent $12. And then let's go ahead and divide. Okay, negatives cancel, 5's cancel, and we get this. On the right side, the negatives cancel, but 12 does not divide by 5 nicely, so you can leave it as 12 over 5. All right, that was a very intricate question, but the concept was making sure that you get those absolute value bars by themselves before you split them up into the two cases. Okay, we'll be working on these for the next few days. So if you're still struggling with these, don't stress out over it. We'll be doing some more as we go. And always, you can always reach out to me if you guys need help with assignments. Just send me a message on Teams.